So what we're going to be doing is it says evaluate the limit for a given value of x and a function f. We're going to be finding the instantaneous rate of change. Okay, we're looking not at the average rate of change because we're looking at a particular instant. This is the instant where we're looking at one little specific x value. And we're going to analyze this by looking at the limit of what's called the difference quotient. So let me write that out for you, okay? The limit of the difference quotient looks like this. The limit as h approaches 0 of f of x plus h minus f of x all divided by h. So what do we mean by that? Well, let's pretend we had a graph. And this is x, right? And this right here is the value x plus h. Well, what's the difference between these two values? H, okay? So if suppose we're getting really close to some number, let's say that this is, maybe that's not the best curve. Say that, I want to find out what is the slope here. If I could draw a line, maybe tangent to that, and let's say pick it in red. Let's say I wanted to find the slope of this line right there. Okay, so I'm going to use the concept of the secant, all right? But what I'm going to do is I'm going to make this h value really small. Okay, so this h value is going to be so small that the difference is going to be basically virtually nothing. That's why we say the limit as h approaches 0, because you're going to make your h value down here relatively small, like almost nothing. It's the point, the secondary point that you're finding. And let me change color here so you can see it. The secondary point that you're finding has to be like really close, okay, and on the curve. So we're going to make the difference between x and the x plus h very small. Okay, so let's go ahead and take a look. And what I do here is I break this up by coming up with each component of the difference quotient. So I call this the baby steps approach. So first thing I want to do is I want to find f of 8. All right, so I'm going to find f of 8 by plugging it in. 4 times 8 squared. All right, I do that. 8 squared is 64 times 4. That's 256. Now what I'm going to do is I'm going to find f of 8 plus h. Because notice what it says, x plus h. This is x, so f of 8. All right, so let's take a look at, let me write that out maybe. F of 8 plus h minus f of 8 all divided by h, and it's the limit as h approaches 0. How about that? So that's why I'm breaking it up into all these little components. It'll make it so much easier when I put it all together. Okay, so what is this 8 plus h? It is 4 times 8 plus h squared. All right, now this right here is what we call a binomial square. All right, so let's refresh our memory for a second. What is a binomial square? Well, in this case, we're looking at a plus b square. So that's a square plus 2ab plus b square. All right, it's a factoring or rather an expanding technique when you're multiplying. It's a special product. Okay, so we're going to have our 4 outside. We square the first 8, which we get 64. We're going to get 2 times 8 times h, so that's 16h plus h squared. Okay, we get that right there. And then we go ahead and distribute the 4. And you end up with 4 times 64, which is 256. 4 times 16h, that's 64h. And 4 times h squared is 4h squared. Okay? You end up with something that looks like that. All right? So we've got that for you. And now we're going to piece it all together. Okay? So let's go ahead and see what it is that we need. I'm going to write that function, or rather the limit, out one more time. And let me see if I can erase this binomial square business here. Give myself a little bit of room. You already wrote that anyway. The limit as h approaches 0, f of 8 plus h minus f of 8 all divided by h. What does that look like? Okay, now let me pull up my highlighter. I have f of 8 plus h. It's this right here. So that's one of the first things that I'm going to write down is I'm going to say, okay, the limit as h approaches 0 of 256 plus 64h plus 4h squared. All right, all of that minus f of 8, and I'm going to pull up my highlighter again so I can find and identify f of 8. F of 8 was this part right here, 256. All right, 1 second, switching my pen. There we go. 256. And then all divided by h. So when I combine like terms, well, what ends up happening? You end up canceling out the 256. All right? So you're left with something that's actually really nice. It is the limit as h approaches 0 of 64h plus 4h squared divided by h. Now, you can't plug in 0 just yet because you would have a 0 in the denominator. So what you do is you divide out that h from everything. Okay? You're kind of reducing it in a sense. All right? So 64h divided by h then is 64, and 4h squared divided by h is 4h. And you end up with something like this. You now can plug in your 0, but 4 times 0 is just 0 itself. So that's gone. You're left with 64. All right? You're left with 64. All right? So nothing to it there. All right? If you need to, pause the video, but we're going to take a look at another example. And this one right here is just a little more difficult. Okay? Just a little more difficult, but only because it's got a square root, but don't get scared. All right? Don't get scared, as the kids say these days. F of 3 equals square root of 3. All right? That's no biggie. F of 3 plus h, that's also not a big deal. 3 plus h under that square root. All right? I've got my components. I'm going to write out my difference quotient. The limit as h approaches 0 of f of 3 plus h minus f of 3 all divided by h. Now let's substitute what we know. Limit as h approaches 0, it's the square root of 3 plus h minus the square root of 3 all divided by h. So what we have to do here, and I think we've probably seen it in another problem, is we have to multiply by the conjugate. And doing that, multiplying by the conjugate, creates a case of the difference of two squares. So you've got to know what dots is, the difference of two squares. It comes into play a lot when you're working with difference quotients, I think. So especially when you're dealing with these kind of radicals, rational functions that have radicals in them. So it creates a case of the difference of two squares, and what we end up with is something that looks a lot like this. You square the square root, you get rid of it, you're left with 3 plus h minus, and you square the square root right there. Sorry, you're missing a square root. Square the 3, or square the square root of 3, you end up with 3 all divided by h times the square root of 3 plus h plus the square root of 3. All right, you end up with something like that. And if you notice there, the 3's end up canceling, and you can actually cross out an h over h, leaving you with a factor of 1. All right, and what does that look like? Okay, let me switch out my pen one more time. I wish it were easier. The limit as h approaches 0 of 1 over the square root of 3 plus h plus the square root of 3. You end up with something like that. You can plug in your 0, but you end up with something like this: 1 over the square root of 3 plus the square root of 3. Okay, so how many square root of 3's do you have? You have 2 of them. All right, you have 2 of them. So you have 1 over 2 square root of 3. And now you might know from college algebra, it's not good to leave those square roots in the denominator. So we rationalize the square root of 3, the square root of 3 on the top and the bottom. You end up with something like this, the square root of 3 divided by 6. All right, and we end up with something really nice like that. And that's a little bit on how you can do a little bit more algebraic manipulation with these things and utilizing the difference quotient. It's really nice. I'm a big fan of the difference quotient, and this difference quotient, the limit of the difference quotient, is one of the foundations of differential calculus. I'm not going to give away the big secret right now, but this right here, maybe it looks like a pain in the butt right now, but it's going to get much easier, I assure you. All right, but right now we must learn how to crawl before we can walk and then eventually run. All right, so I hope this video was helpful, and as always, like and subscribe.